Hey guys, today we're going to learn about Notes 2.2. This will be a review in consideration of quadratic functions. So to get us started, we have two graphs in front of us. We will graph a quadratic function. We will start with the first one and label it y equals x squared. You'll notice that there is a value out front of that x squared, and we will make sure that that a value in this example is going to be a positive. All right. With that being said, if we were to graph this, it would be a U shape. Quadratic functions are always in the shape of a U, whether that's opening up or opening down. And it will look something like this. Now it will go up this time because it is positive. In the next example on the graph to your right, we will have the function y equals not a positive x squared this time, but a negative x squared. Noticing this here, your a value is a negative. What that does to our graph is that instead of opening it up, it will take our U shape and flip it about the x-axis and make our graph open down. Okay. Now, as a refresher as well, we want to talk about our domain and range for quadratic functions. So domain we will label with D, and domain is always in terms of your x values. So keep that in mind, domain x values. And when you think about the x-axis, think about the direction in which you read a book. You want to go left to right. So we want to take our furthest point left all the way to our furthest point right. Now, if you look at your function on the first graph, if you look at your graph, your picture, you will notice that on the left-hand side, yes, your arrow is going up, but it's going up and to the left. So when we label that, we know that it's going all the way to negative infinity in terms of x. And on the right-hand side, it's also going up again. However, it's going up and to the right all the way over to positive infinity. Now, if you remember your notation here, whenever we have infinity symbols, we always want to use parentheses. Okay. When we do that, we also want to talk about our range. Range has to do with our, not x values this time, but our y values. All right. So when I talk about range, you kind of want to think of the opposite of left and right. You want to go from the bottom to the top. That is the most important, bottom to the top. So with respect to y values, we want to look at our function. Our lowest point is going to be right here. We'll call that 0, 0. But when we pull for our range, we are not pulling the x value. We are actually going to pull that y value. So it's going to start at the bottom at 0. And then the graph takes us all the way up in both directions, all the way up to positive infinity. All right. Again, we have infinities on the right-hand side, so we want to use parentheses. And when we get to the 0, you're going to say, well, it does actually equal 0, 0 at that bottom point. It is included. So we don't want parentheses. We actually want brackets. All right. Moving on to the second example, we're going to do the same thing. And we're going to look at the graph and see how that pertains to our domain and range. So again, for domain, you're going to look left to the right. And from the furthest point left, again, it is going to start from negative infinity. And all the way to the right. Yes, it is going down, but it's going down and to the right. So it's going all the way to positive infinity. Close off your values, both with parentheses. And then we can move on to our range. All right. Our range here is going to change slightly in that our bottom value is going to be a negative infinity. That's the lowest value it can possibly be. And then as it moves all the way up the function, all the way up the graph, it's going to stop at this point here, which is again 0, 0. So it's going to go all the way up to the tallest point, the highest point, which we will call 0. And again, parentheses around the infinity and a bracket around the 0. Okay. That being said, we can move on down And I just got to figure out how to do that. There we go. Okay. Here we have standard form. There are 3 forms of a quadratic function. And those forms consist of standard form, vertex form, and x-intercept form. So we will go over a few key features of standard form and move on to our vertex and then our x-intercept. So to get us started on standard form, we want to make sure that we are talking about 3 different things. You will notice there are 3 letters here. We have A, B, and C. In standard form, A, B, and C are going to help us tremendously as we figure out the rest of our vertex, axis of symmetry, and x-intercepts for this specific form we are talking about. So if we move down and we look at the vertex uses this special formula, okay? You'll notice the 2 letters B and A are referencing the same A and B up above. All right, so as soon as we know what those values are, we can plug them into that function and get going. This only, however, gives you your x value, but in your vertex, it's a coordinate, so you will need 2 values, both your x and your y. So once we have our x, we can plug in our value and solve for y, and you will see that in an example here shortly. Then there's the AOS, and this stands for axis of symmetry. It's that straight line that goes and splits your graph perfectly in half so that half your graph is on one side and the exact same half reflected is on the other side. All right. And that function is always going to be x equals, and it's always going to equal the x value of whatever you had up above from your vertex. That's what's going to split it in half. All right. And the next piece is your x-intercepts. There are 2 ways to find your x-intercept. You might notice this to be your quadratic formula. But there's also another way that you learned back in Algebra 2 and even in Algebra 1 that can help you find the x-intercepts of a function. And for some, it might be a lot faster. I definitely like this form a lot more. However, it is not going to work every single time, but if you like this, we can always check it out first, and that way is through factoring. All right, so again, key things, quadratic formula. If we don't like to use the quadratic formula, we can always check in on our factoring skills. All right. Our second form is vertex form, and it's just like the word tells us. Vertex form is indeed going to tell us our vertex, which is awesome. All right. Here on vertex form, you have the A out front. Okay, that is actually the same A as up above. So if you want to relate them, I would. That A value tells you positive is going to open up, negative will open down. However, please pay attention here. When it says minus h in the function, make sure that you point out that your vertex does not have a negative sign out front, so that you always need to remember that, oh my gosh, there we go, that your h value is always opposite of what you see. So for example, if this said x minus 5, then your h value wouldn't be negative 5, it would actually be a positive 5. So please keep that in mind as we identify our h values. Then we have our axis of symmetry. Again, same idea. It's the x value from your vertex. So I understand it says h. Don't get that confused. It is still your x coordinate from your vertex that they just pulled out, and they're going to give you for your axis of symmetry. And last but not least is your x-intercepts. And what you are going to do is you are going to solve for x. This will take some time, All right, you will see that in an example here shortly. It is some time, however, it's extra practice for us, and it's never a bad idea. All right. And the last one, x-intercepts, I highly suggest that we go ahead and we flip this around just slightly. So instead of saying f of x equals all of that, let's call it f of x equals, and we're going to put a out front, okay? I know I've been referencing a already and twice above. It's going to be the same a we are talking about. That's why I'm going to have us rewrite it, because the a inside those parentheses is talking about something slightly different. So what I'm going to do is I'm going to have an a out front, and instead of having x minus a and x minus b, I'm going to have an x minus the letter p, and then an x minus the letter q. All right. And as we go through these notes, I might call this the x-intercept function, because it is indeed going to tell you what your x-intercepts are. Or I may also call this our factored function. Okay, so if I call it factored, I'm talking about x-intercepts. And if I call it x-intercepts, you can also refer to it as the factored function. All right. Now for this one, obviously, if it is the x-intercept function, then it's going to tell you right away what your x-intercepts are. So in our case, with our new function that we labeled, it's going to be x equals whatever the positive value or the opposite value of p is, as well as the opposite value of that q. All right. I highly recommend that when we go and we graph these, if you're given this x-intercept form, I highly recommend this is what we graph first. And the reason I say that is because once we know our x-intercepts, then we will have 2 points on our graph, and then we can go straight to finding our vertex. So if you're one of those visual learners who likes to see things a little bit differently, I highly recommend, again, on your x-intercept form or your factored form, let's graph those factors first, and then we can move back up to the vertex and identify from there. Okay. Again, when you find your vertex, you will only be able to identify your x-intercept. In order to find the second coordinate, the second piece of the coordinate, that y value, we will need to take whatever that x value is on our graph and plug it into the function and solve very quickly to find our y value. All right. Again, we will have all of these in our notes here shortly on how to graph. So the next 5 things are your graphing quadratic functions. Some key things I'd like to add as well is before we even get started, I want us to identify the form. Okay, we didn't just go through all 3 forms if we don't know how to identify them. So before we get started, I want to identify if it's in standard form, vertex form, or x-intercept / factored form. Once I know what form I'm working with, these 5 steps will be a breeze. Okay? So as we go through, identify our forms. Then step 1, determine whether the function opens upward or downward. Again, that's all in reference to whatever our a value is. Step 2, find the vertex. 3, find the x-intercepts. 4, find the y-intercept. And 5, any additional points if necessary. Now, one thing I do want to point out is we only need this if we need to get to 3 points. So what I mean by that is when we do all 5 of these steps, if we just have the vertex and the x-intercepts don't give us a point, or the y-intercept doesn't give us a point, we want to have at least 3 points on our graph so that we can connect the dots and make our U shape. If we don't have those 3 points, then our U shape isn't going to be as precise, and we won't necessarily know where the next coordinates are that can create our graph. But we'll see if we need them in the examples to come. So let's start with question 1. We're given a function, f of x is equal to -2 parentheses x minus 3 squared plus 8. Now before we get started, let's figure out what form it is. It has parentheses, it has an a value, an h value, and a k value. And in that case, we will identify this to be in vertex form. Now, what's special about vertex form, again, you can slide up to page 1 if you would like to review it. Vertex form has 3 distinct letters that go with it. We have A, H, and K. Now, I want to label what those values are because, again, they will help us as we go through those 5 steps. So our A value, if we match it with vertex form from page 1, is the value out front of those sets of parentheses, and we will label it as -2. Our H value inside those parentheses is going to be the opposite. So we see a -3, but we're going to take a +3 out for our H. And last but not least, your K value is at the very end, and we will keep it just as we see it at a +8. With all of that labeled and ready to go, we can start on our 5 steps. So we will start with step 1. Step 1 is determining if it's going to open up or open down, and that is all based off of whatever we have for our A out front. So yes, it's a 2, but more importantly, it's a -2. And because it's negative, it's going to make us open our graph down. So when we get our picture, we will make sure that our graph is opening down and we can go from there. Step 2 is to identify our vertex. Well, it just so happens that we happen to have vertex form in this example. So if it's in vertex form, just like the form insinuates, we should know our vertex. And we're going to take exactly what we just labeled, our H value of +3 and our K value of +8. And as soon as you know something, I highly suggest we take that information and we go ahead and we plot it on our graph. So we have 1 point right now. We want at least 3. And if we get more than 3, all that's happening is you're just making your picture more precise. So we may or may not end with 5 points in the end. And I will show you why you want to shoot for 5 points. Otherwise, 3 points will do just the same. 5 points just makes it more precise. So moving into step 3, we want to find and identify our X values, our X intercepts. In order to do that, think about anything that is on this X-axis. We're finding the points in which we are crossing and touching this X-axis. Well, at any point on this axis, think about what your Y values are going to be. If I chose a random point here, my coordinate would be -6, 0. If I chose a regular or random point over here, my coordinate would be 8, 0. So think about what those values mean. What is never going to change? What is your Y value at those coordinates that I just labeled for you? And if you think about it, you will notice that your Y value was always 0. So what you're going to do is you're going to switch out that f of x in the very, very beginning of your function right here. You're switching that out with a 0 because you know at those coordinates, your Y value is going to be 0. This is how we're going to solve for x, just like the paper said above. So with that being said, as soon as I swap that out for 0, I am just going to copy down the rest of my function that I have taken straight from above. Now with this here, look at the only variable that is remaining. It's only just x, meaning now we can solve for x. So in order to do this, we need to work out some PEMDAS. We need to go back to remembering our rules on how to write all of this out. So let's start with those parentheses, but more importantly, those parentheses had an exponent of 2. What that means is we need to write that set of parentheses 2 separate times. Once we do that, we have 2 sets of parentheses right next to each other, so we are going to FOIL, or you might know this as double distribution. So as soon as I use double distribution, I'm going to go back to green here so we can follow along. When I do x times x on the inside, it's going to come out as an x squared. Then I'm going to distribute out to the next term. X times -3, it's going to give me -3x. Change colors here for you. On the insides, negative 3 times x, again, is going to give me negative 3x. And the last one, negative 3 times negative 3 is going to give me a positive 9. And I'll go back to blue just to show you that I'm still going to keep taking down my 8. I brought down my negative 2 out front, and I brought down my 0 as well. So the only thing that changed here was the set of parentheses because I have distributed. All right. After that, let's simplify those parentheses really quick just to make it a little bit cleaner. So I'm going to keep everything, but when I get inside, I'm going to get to combine my like terms in the middle. So a negative 3x and another negative 3x is going to give me negative 6x plus 9, and then again, bring down my plus 8 one more time. All right. From here, we can now distribute that negative 2 in. So in order to do that, I have a negative 2x squared on the first term. Distribute one more time. Negative times a negative is going to give me a positive. 2 times 6 gives me positive 12 and a single x. And the last term, negative 2 times positive 9, gives me negative 18. Now we can't forget about that plus 8 at the end there, so I'm going to bring it down one more time. And I can simplify one more time. So I will have 0 equals negative 2x squared plus 12x. And these two terms here can combine because they are like terms. And I will have negative 10. Now, remember, our rule for step 3 here was to solve for x. Look at your x values or look for your x variables. And are they solved for? Meaning, does it say x equals this and x equals that? All right. Your answer for that question should be no, so we have to take it a little bit further. And you can do that one of two ways. We can use the quadratic formula using our a, b, and c values from this function that we have now, or we can see if it's factorable. All right, in this case, I'm going to see if it's factorable just because I like factoring a little bit and a review of factoring is much needed at the beginning of the semester. So to do that, I'm going to look over my coefficients in front of my terms. I have a negative 2, a positive 12, and a negative 10. I happen to see that negative 2, positive 12, and negative 10 all have they all have a common multiple amongst all of them. So what that means is they all have a 2 in common. And more specifically, because that first term is negative, I'm going to say that they all have a negative 2 in common, which means that's what I'm going to take out of each one of those terms. And because I took out a negative, all those terms are going to flip their signs. So for example, in that first one, when I take out that negative 2 in front of negative 2x squared, I will be left with just x squared. When I take out a negative 2 from a positive 12x, it will give me a negative 6x. And last one, when I take out a negative 2 from a negative 10, that will give me a positive 5. Now this function that I have inside my parentheses is going to be easily factorable. And what I mean by that is I can look at this because my a value in the very, very front of that x squared is a 1, I can ask myself the quick question of what multiplies to give me the first term times my last term. So I'm going to say 1x squared times 5. So what multiplies to give me 5x squared and adds to give me that middle term of a negative 6x. You're looking for the same two numbers. So if I thought about this, my only options for multiplying to give me 5 is a 1 and a 5. So if I filled that in, of course filling it in with x's in order for it to satisfy the rules here. For this top line, 1x times 5x does indeed give me 5x squared. But on the second line, a 1x plus 5x does not give me the negative 6x that I'm looking for. So in order to make that happen, I need to make these negative. Well, I can't make these negative if I don't also make the ones above negative. And do a quick check. Is negative 1x times negative 5x, 5x squared, is it still going to come out to give me a positive? And your answer is yes, so it will check out. And the bottom one, a negative 1x plus a negative 5x, will also give me a negative 6x. And the reason we like to do it this way is because once I know that this works, and once I know that that a value in front of my x squared was a positive 1, I know that I can simplify this with those exact two factors that we just found above. And I'm going to use purple so we can match it up. So in my parentheses, I will have an x and an x. And the two factors that we just found are going to drop down. So I'll have an x minus 1. That was my first factor I had. And then an x minus 5. And we're that much closer to finding our x-intercepts. From there, we need to take these two sets of parentheses and individually set them equal. Oops, pardon me. Let's go back here. Individually, set that function, set that set of parentheses equal to 0. And I did it again. Here we go. And an x minus 5 equals 0. All right. Then we can do a quick solving for x. So in order to get x by itself here, I need to add a 1 to both sides. In order to get x by itself here, I need to add a 5 to both sides. So for step 3, again, this was all in step 3, we have x-intercepts at x equals 1 and x equals 5. So we can take that information and put points at x is 1 and x is 5. All right, 3 points here on my graph. That's awesome. I know that my graph is going to open down, considering that's my vertex up there at the top. And I have 2 values down below that I can connect it with. However, I have at least one more step to keep going with. That is step 4. Step 4 is all about your y-intercepts. Well, again, just like we did with our x-intercepts, we saw that when I'm on the x-axis, my y value was always 0. But in this case, when I'm on step 4, I'm asking myself, when I'm on the y-axis, what is my x value going to always equal? And in our case, our x value is always going to be 0. So just like we did in step 3, we're just going to flip it. So we still have f of, and again, we just identified that x has to be 0. We're going to switch out every x value to be 0. And we're working on the function that was given to us right above on this example. So every time I have an x, I'm going to plug in a 0. And we just work out the problem. I have a negative 2 on the inside. It gives me a negative 3 squared plus 8. Simplify that. A negative 3 squared is going to give me a positive 9. Negative 2 times positive 9 gives me negative 18. And finally, this comes out to give me negative 10. So what that tells me is that on my y-axis, my y-intercept should be all the way down at negative 10. So that is point number 4. What if I told you we could find a 5th point that's going to work for this graph as well? Notice how between my x-intercepts, they are split evenly from my vertex. The same rule applies for this last point that we just found. That 0, negative 10 is going to be split evenly from my vertex as well. We call that our axis of symmetry. That's the line that's splitting our graph in half. So if I go back here, if I have this point at 0, negative 10, and it was 3 units to the left of my vertex, then I can have the exact same point on the right-hand side of my vertex that is also 3 units, but this time to the right. So I can put another point, we call that a reflection point, at the coordinate 6, -10. And with all that information, I have 5 points that can allow me to have a perfect graph, a more precise graph, and I can connect the dots, making sure that at my vertex I am changing from increasing to decreasing or vice versa, and I have my graph right in front of me. So when you get to step 5, do we need to have any more points on this graph? For one, nothing else is probably going to fit, or it's going to be a decimal. And for 2, we have plenty of points. We have 5 points. I told you at the beginning we want to shoot for 3. If we can get 5, it's just going to make our graph even better. So for step 5, we're going to say NA. It's not applicable. It is not necessary on this problem. All right. That one was kind of a longer one. It's not going to necessarily be the case moving forward, but that is how vertex form is graphed on a piece of graph paper. All right. Moving down to question number 2, as I have some room a little bit. Question number 2, again, same steps. Not going to take as long. This one, we want to identify the form. X squared minus 4x plus 3. If we compare it to the forms above, we will notice that it is in standard form. And standard form gives me 3 letters I need to worry about. A, B, and C. Get rid of this little guy here. There we go. With A, B, and C out, let's figure out what those values are. A, again, is the letter or the coefficient right in front of your x squared term. So in our case, because there's nothing there, it's not 0, it's actually going to be a positive 1. In front of our B value in front of x is going to be negative 4. And last but not least, our C value at the very end will be a positive 3. All this information is going to help me in my 5 steps. So step 1, is my graph going to open up or open down? Based off of an A value being positive 1, I know that my graph is going to open up. For step 2, in order to find my vertex, I need to have the formula negative b over 2a. So just as a reminder, that formula is going to give me my x value. So in order to use that, I need to know those 2 values for a and for b, and I've already labeled them, so that's one reason why we like to have them labeled ahead of time. All right, and before I plug them in, I'm just going to rewrite the function like this. And the reason I do that is so I don't forget the negative up top, I don't forget I'm dividing, and I also won't forget that there is a 2 down below. Then I can plug in my b value using parentheses because I notice there's 2 negatives there, and my a value down below. Do a quick simplification. I see a negative, and a negative 4 is going to give me a positive 4, and 2 times 1 down below will give me 2. And last but not least, 4 divided by 2 will give me a positive 2 to work with. But we're talking about a vertex here. We need a coordinate. This has just told us our x value. So as soon as I know what my x value is, I can throw parentheses around it, and I just need to figure out how to find that second value for y. So as soon as you know anything about x, we can take that x of 2 and plug it in to my function. That being said, I'm going to say f of 2 equals, and every time you plug something in, please use parentheses, because if you don't, you may look at this like 42. 42. But it's not 42 because we know that we need to be multiplying. So set of parentheses reminds us what's happening. Then I just simplify. 2 squared is 4. Negative 4 times 2 is minus 8 plus 3. Simplify one more time and you should get a negative 1. And that negative 1 is going to be what gets put in for our y value on our vertex. And once we know that, we can plot a point at 2, negative 1. Then we can move on to step 3. Again, I said problem 1 was going to have the longest step 3 that we'll see. So this one will be a little bit easier. Since this one's in standard form, again, we can solve it one of two ways. We can use the quadratic formula, or we can see if it's factorable, and if it is, we can factor it. So if I have x squared minus 4x plus 3, I'm going to do those same steps I did up above. I'm going to say what multiplies to give me my first term and my last term, so 3x squared, and adds to give me that middle term of a negative 4x. All right. And that being said, the only two numbers that are ever going to multiply to give me a 3 is a 1 and a 3. So I'm going to fill in both. And of course, don't forget your x's. So right now up above, we have 1x times 3x is going to give me a 3x squared. That does check out. However, a 1x plus 3x does not give me a negative 4. So I need to work with some numbers here and see what I can make work. And more often than not, we just got to work with some negatives. So if I look back at the top, if I make this 1 a negative times a positive is going to give me a negative number. Well, I don't want a negative number at the end. I want a positive. So I got to make sure that I make both negatives and see if that will work. Moving down to the bottom, I can't change one without changing the other. So let's do a quick check. Negative 1x times negative 3x up above will give me that positive 3x squared. So that checks out one more time. And a negative x plus a negative 3x will also give me a negative 4x. Now, I can use that cheat method we used up above, that shorter method, the easier one, where since I just found these values, and since my a value out front was a 1, I can go straight to my factored or my x-intercept form. With my x's first, and then I fill in with the two factors I just found, a -1 and a -3. From there, I can set each factor equal to 0. Let's write that one more time. Do a quick solving by adding 1 to this equation, so your x is a positive 1. Adding a 3 to this equation here, so your x is a positive 3. Again, this information just told you your x-intercepts, so we can put a point at 1 and a point at 3 on our x-axis. 3 points down, let's try to see if we can get 2 more. Going on to step 4, we want to find our y-intercept. Again, in order to find your y-intercept, you want to replace all of your x values with the number 0. Again, when you replace x values, make sure you're using parentheses, just so you don't look at that and think that it's 40 instead of 4 times 0. Work out the numbers really quick. You have a 0 minus 0 plus 3, which will give us 3. That's our y-intercept, so we can put a point at 3. And then based off of how we got the 5th point on that last graph, how would you find the 5th point on this graph? Go ahead and see if you can locate where that is going to go. right? And if you did look and you saw that this point here that we just graphed was 2 units to the left of my vertex, then I want to plot the exact same point but 2 units to the right. So if I do that, it's going to be on the x value of 4, comma 3. I'll erase this. Okay. So your reflected point should be here at 4, comma 3. And with all 5 points there, we can connect the dots. We have a nice looking graph. It's opening up just like we identified in step 1, so we are good there. And ask yourself, do we need more points? No, we do not need more points. Okay. Go ahead and look at question 3 for me. I will let you do question 3 on your own. And I have posted, or I will be posting, the answers to notes 2.2. And by answers, I mean just my teacher notes. All right, so if you have my teacher notes, or if you want to look back at question 3, please go back, see what I have posted from my teacher notes, and you may compare your answer with what I have posted online on Teams. All right, you'll notice it's in vertex form. We've already gone over a vertex form question, hence why we are going to skip down to question 4. All right, here on question 4, again, same steps that we've been working on. First, identify the form that we are working with. So in this case, we have our x-intercept form, or if you'd rather call it your factored form. All right, and with that said, we have 3 letters yet again. We have our A value that's out front, and then we have those odd ones that are the P and the Q's. All right, remembering that they're opposite, just like H was in our vertex form. So our A value out front is going to be a -1 this time. Our P value on the inside is going to be the opposite of what we see of that first set of parentheses. So our P value on the first one's a -3. And our Q value, again, is the opposite of what we see, and it will be a +1. All right. Then we move on to our steps. Step 1, identify if it's going to open up or open down. Our A value is negative here, so we see that it's going to open down. Step 2 is to identify the vertex. I told you earlier that on factored or x-intercept form, we kind of want to work a little bit backwards on this one because it's going to give us our x-intercept. That's probably what we should graph first, especially if you're one of those visual learners. This will help you a lot. And so I will hold off on step 2 for now, and I will go straight to step 3. Step 3 was our x-intercepts, which just so happens to be the form that was given to us. So we're going to pull the 2 values we've already identified, which is my P and my Q, and those are going to be my x-intercepts. So my P value was -3, so that's one x-intercept, and my Q value was a +1. Once I know that bit of information, I'm going to go over to my graph, put a point at -3, and put a point at +1. Now, we talked about this earlier, that when you have your x-intercepts, in order to find your vertex, it's going to be the coordinate, the point in which you are exactly halfway between your 2 x-intercepts, remembering that our vertex will always split our graph in half. So, with that being said, from -3 all the way to +1, I've gone a total of 4 spaces, 4 cubes, if you will. So as I have 4 cubes, or 4 spaces, the halfway point between those is going to be right here. So you'll only know your x value, but you know that your vertex is going to lie anywhere on that x value of -1. So that being said, I'm going to know and identify that my vertex is going to have an x value at -1. Again, that's because it's the halfway point between both of my two x-intercepts. Now I can't plot a point quite yet for my vertex because I don't know where that y-coordinate is. I know the x, I don't know the y. And if we remember from above, whenever you know the x, we can plug it in and replace all of my x's with -1. I'll show you that here in red. And then do a quick simplify. Negative out front, and this comes to a 2, and this comes to a -2. Simplify one last time, and you should get -4. That right there will be your vertex, your y-coordinate on your vertex. And now we know the exact point that I can graph. And last but not least, step 4, looking into our y-intercept, we want to replace our x value again, not with a -1 like we just did, but with a 0 because we're talking about the y-intercept. So when I plug it in, plug my x in for 0, let me write the correct function here. I want to do a quick solve. This gives me a 3, and this is a -1. Simplify one last time, and I'll have a +3. So at 0, +3, I will have my y-intercept. Let's see what happens. All right, let's go ahead. All right, so from here, let's go ahead and simplify. And we should get a +4, and that +4 is going to be my y coordinate on my vertex. And once I know that, I can go to my graph and I can plot -1, 4. So I have 3 points now. Let's go ahead and see if we can get 5 points on my graph. And let's do that by going on to step 4, identifying my y-intercept. All right. And just like before, instead of plugging in a -1 for my x, because I'm talking about my y-intercept, I want to plug in a 0 for my x. So I'm going to replace everything in my function. Everything for x is going to turn in to a 0. I can simplify this really fast, and I have a negative times 3 times -1, which will give me a +3 in the end. And I know that at the coordinate 0, +3, I will have a y-intercept. That's my 4th point on my graph. Again, go ahead and try and see if you can find your 5th point. And if you found your 5th point, it should be a direct reflection and land at exactly -2, +3. Once you have your 5th point, we can connect the dots and make our U shape, our parabola. And once more, our fifth step was not needed. However, if this was ever needed, what could you always do to find more points on your graph? You can always make an XY table that looks something like this. And all you do is you just plug in random values for x. So for example, if I know that my point here is at 1, what if I wanted to know where a point was when x was 2? I would take that 2, I would plug it in to my function like you did in step 2 for finding your vertex, as well as step 4. Plug it in, find your value, and that will give you your exact y coordinate for another point if you need it. All right. Again, here we didn't need to do step 5 because we already have 5 points. You can go on and get more points if you'd like. All you're doing there is just making your graph more precise. So as we move down, we're almost nearing the end of our notes here. We want to talk about domain and range one last time. We talked about it at the top of our notes, and we just want to make sure that we know the difference between domain and range and how to use it in respect to graphs. All right, but you will notice in these two examples that there are no graphs. So we have to think about and visualize some sort of picture and see what we are working with. All right, but as we get started, again, think about the same procedures. Identify the form, think about what A is going to do to your graph, and then the last bit of information that we're going to need here is our vertex. So here on question 1, we have standard form, which means we have an A value of -1, a B value of -2, and a C value of +3. Our A value here is going to tell us that we are now going to open down. So we are going to have a graph. I'll just do a quick sketch here. A graph that's opening down. The last bit of information I need to know about this graph, as I lost it. Go back down here. Okay. The last bit of information I need to know about this graph is that vertex. And the reason I need to know that vertex is because it's talking about my lowest point and my highest point. I need to know what that vertex value is so that I can use it for my range. So let's find our vertex. It's in standard form. How do we find a vertex in standard form? We're going to use the formula -b over 2a. Again, labeling my negative, my division sign, and my 2. Plug in your values and simplify. I'm going to work downwards here at an angle, and that's going to give me a -1. That's just the x value on your vertex. We need to know also our y value. So if I took that -1 and I replaced it for all my x's in this function, and I solved, I should be getting a +4. Go ahead and double check that. See if you agree, disagree. Don't forget that this negative here is going to make that a -1 as soon as you square it. It's going to still keep it a -1. And this will indeed come out to give you a +4. So I know that my vertex is at -1, 4. Now with my sketch given, I can determine my domain and my range. Domain is your x values from left to right. Well, looking at my sketch, all the way left, yes, it's going down, but I'm concerned about all the points on the left-hand side. So it's going all the way to -infinity. And then on the right-hand side, Yes, it's going down again, but I'm not concerned about it going down. I'm concerned about it going down and to the right. So it's going to positive infinity. They have infinity, so I want to make sure parentheses are around both. For my range, however, range is your y values. You want to go from the bottom up to the top. So my bottom is here. They both have arrows pointing down, which means it's going on and on forever, downwards, all the way to negative infinity. And then as it moves up, it's going to touch that vertex and obviously can come back up this way as well. So it's coming all the way up to that vertex value, and I'm not going to say -1 because it's the range. I am concerned about the y value here. So it's going all the way up to a positive 4. I can put parentheses around the negative infinity, and it does equal that 4, so I'm going to put a bracket there. And that is our final answer for this question. So if you need to graph it out or you need to do a quick sketch, by all means, you may. Let's do question 2. This is in vertex form. We have an a value of positive 3, h value of -5, and a k value at -4. And since it's in vertex, it actually gives us everything we need to know. Our a value is going to tell us we're going to open up, and my h and k values tells me it's at a vertex of -5, comma, -4. So with that bit of information, I know that I have a function or a graph going up and that the vertex is at -5, comma, 4. So with this sketch here, go ahead, I'll give you a minute. Go ahead and see if you can find your domain and your range. And as you looked for your domain, you'll notice that the pattern is going to continue. The pattern is always going to be for a quadratic function, for those u's, for those parabolas, your domain will always look like -infinity to positive infinity. And then as you get to your range, that's the one where we have to pay close attention to. So all the way at the bottom, your y value, oops, and it looks like I labeled this incorrectly. Your y value shouldn't be a positive 4. Your y value is actually a -4. So it's going to start at -4 and go all the way up in both directions up to the value positive infinity. And once you have those, we just have to fill in our parentheses and the bracket on -4 because it is indeed equaling that value on my vertex. And we are all set on example 2. And the last two questions, or the last question of the day, is to use the quadratic function f of x is equal to -3x squared plus 6x minus 13, and use that function to determine if the function has a minimum or a maximum value. Okay? And what that means is it's going to be a minimum if it has a low point and a maximum if it has a high point. Well, how are we going to determine the differences between a graph opening up and a graph opening down? We've been doing that this entire set of notes, okay? That's going to be determined directly by whatever our a value is in the very, very front. So here our a value was -3. And because it was a -3, that tells us that our graph is going to be opening down. We'll take a look at a graph that opens down. Do we have a maximum value there, or do we have a minimum value there? And your answer when it's opening down is going to be a maximum value right there on our graph. So to answer part A, we have a max. And then the last part for find the min or max value, well, we know we're not finding the minimum value. We are indeed finding the maximum value. And think about where that maximum value is going to lie. That maximum value is right here. We've been talking about that all day in our notes too. That value is talking about our vertex. What kind of function were we given again? This was in standard form. Do we know how to find the vertex in standard form? Yes, we do. It's that formula, x is equal to negative b over 2a. And I copy it down with the negative, the division, and the 2. And I will fill in my b value of a positive 6 and my a value as negative 3. Simplify really quick. And it's going to give me an x value of 1 on my vertex. All right, but that's not just the only point I need. I need to also know my y value. So throw a set of parentheses around there. Let's find that y coordinate. So I'm talking about an x value of 1, and I'm going to replace every x value with the number 1. And once I've done that, I can work out the problem. I have negative 3, 1 squared is going to give me a 1, plus 6, 6 times 1 gives me 6, minus 13. Keep going here. I have negative 3 plus 6 minus 13. And this should give me a negative 10 when I simplify. That negative 10 is the y value we were looking for in our vertex. All right. But the key detail here when it's asking for your max or your min, it's concerned about your y. What is your y value on that maximum point or on that minimum point? So we aren't too concerned about the x value here. We want to know that our maximum is going to be at negative 10. All right. So again, go through these notes, watch this video more if you need to. However, I am posting the teacher notes for especially question 3. Go ahead, look over question 3, see if you can do that on your own, and then check the teacher notes, see what we might have done, and if you still have questions,